Hi, welcome to your first lesson in math in fifth grade. We are going to be exploring place value together as our first lesson. Now, place value is something that's been happening all along since you've been talking about numbers and values. However, every single year with math, if you haven't noticed already, it builds upon one another. So place value for fifth grade is going to feel very familiar, hopefully. So we're going to be looking at knowing and identifying the different place values, but more importantly, how the different place values relate to one another. So if a digit is in one place value, what's the value of that digit and how does it change in a different place value if we were to have that digit there? So for lesson one, you are going to record your own notes. You have a couple options. You should see on your Canvas page that there is a PDF link if you have the ability to. You don't have to, but if you have the ability to print those notes at home, you can, and then you'll be following along identically with me. But it's also a really great skill to get used to listening and recording the information down on your own paper too. So that could look like a blank piece of paper, that's a computer piece of paper, that could be a lined blank piece of paper. I'm really going to suggest you stay away from post-it notes, index cards, and things like that. It's going to get a little small. Now, no, when you're on your own paper, you're not really going to see some of the images. You don't have to draw every single image that I show. So the main pieces would be the recording of different vocabulary words and different kind of movements that I'll make sure that you get written down as well. You could also just have up the notes as well to kind of refer back to eventually as well. So let's get started. So the first thing let's review is if I have this number right here, I'm curious if you know how it's read. So how would you say this number mathematically correct? I see that there's digits. So the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are digits. But when digits are in a place value, we say them in a different way. So how would you say this number? Well, hopefully you would have said 8,675 and 309 thousandths. So knowing those place values is important for you to be able to say the number correctly, because we can't just say 8675 decimal 309 and communicate that we know the value of those numbers. So now that we've talked about saying it, and we'll keep practicing that if you weren't able to get it, let's talk about what are the actual place values here. So this decimal is going to be key for us in knowing what these different values are. So let's maybe start here if you haven't already started thinking about it. So if you're on your own blank piece of paper, I would write this number down and then start writing the place values above each digit. So when we talk about those, you have those recorded too. So this one is the ones place value. And that's a whole number. So anything in front of the decimal is a whole value, not a part of a whole. So decimals being part of a whole. So ones, and then after ones, you are in the what place value? Should have said tens. Now make sure the spelling is correct. These are pretty easy, I know, but as we move forward, make sure your spelling's correct, because otherwise you could seem like you're meaning a different place value, and you have them on your notes to then refer to and have them correctly written for the future. So what's after ones, tens, and then what place value is this 6 in? Should have said hundreds. Hundreds. Okay. Now, what's interesting is these are your key repeated place values. So if you know these three, then you can start building upon bigger place values because it repeats. There's a pattern to it. Now, as far as fifth grade and being in Indiana, your requirement is to go all the way to the thousands place. But that being said, with this pattern, in knowing this pattern, ones, tens, hundreds, you could continue on and on and on. And numbers go on for an infinite amount of counting and continuing this pattern. So after hundreds, ones, tens, hundreds, this is thousands. So sometimes, and everyone gets real caught up on this, but not here, not with me, is that, don't I need a comma? Yeah, a comma is nice. It's helpful for you to see and read the number because it chunks those three place values together to know that you're now in another, they call it in another period. Now we're in the thousands period. So then this one, a little bonus question, what would be after thousands? So that's like the same as ones. Now it's repeating. So then it's 10,000. And then after that would be 100,000, right? So if having a comma allows you to see that we've moved on to the next one. And so you can read it easier, 8,675. So these individual place values, when we read the number, we're not saying 8,607 tens and 5 ones. So we are grouping them quite a bit. And let's go into the parts of the whole. So these are decimals. And after the decimal point, it is what place value? Should have said tenths, hopefully. And what's interesting about this is the pattern isn't quite the same. There's no ones, right? It's like they skipped the ones. And after that, though, so you can kind of see how that relates. So this, guess what this one would be? Hundreds. Now, yes, I know this should be a review from 4th grade. Now, I want to point out a key element here. Spelling matters in this case, that if you do not have that TH, you are meaning a completely different place value. So that TH is necessary. Otherwise, it could be counted wrong if you're asked to identify its value. So then the last one, so tens, hundreds, same pattern, but with the TH, thousands. Squeeze that in with our THS, and I'm going to identify that again, that TH is a necessity there. Okay, so for 5th grade, our goal is to work with numbers that go all the way to the thousands place value. Now that we have reviewed all the different place value names, let's move on to looking at what's happening with those place values. And I'm going to zoom us in here quite a bit so that you can easily see the movement that's happening with this 3. So what place value is this 3 in again? Yeah, it's in the tens, okay? So if I were to move this 3 to the ones place value, it moved times 10. So if it goes to the right, then it's dividing by 10. But the inverse of dividing 10 is 1/10. So you could do either one of those. You could say divide by 10 is going to move my digit to the right, or you could say times 1/10 is going to move my digit to the right because it's that fraction. So when a digit moves one place to the right, fill that in, and you'll want this sentence. It's a nice cheat sheet of, okay, if it moves to the right, then the value is, what do you think? So if it moves to the right, it's going to be times 1/10 of what it was. So it's moving to the right. It's going to be divided by 10 doesn't quite make sense there. If I were to say that in a sentence, just verbally. Now, mathematically, it definitely makes sense. When a digit moves one place to the right, the value is divided by 10. What it was, it's a tenth of what it was. So you could say, you could just have a tenth of what it was. These mean the same thing. So is that divided by 10 actually happening there? Yeah, it definitely is. But as far as the sentence making sense and its value and how it's changing, we would want to use those words instead. So what about when a digit moves one place to the, what about to the left? So if it moves to the left, the value is getting blank what it was. It's getting 10 times what it was. It's 10 times bigger than what it was. So the key things to remember there is moving to the left is times 10, moving to the right, and that's backwards for me, moving to the left is times 10, moving to the right is divided by 10. Okay? So let's put this into practice. So we're working with just single digits here. And this is what is this value? What is this amount? 4 tenths. Good. So if I take 4 tenths and I times it by 10, where's that 4 going to end up being? So times 10, which way does it move? Times 10 is to the left. So if this 4 is moving to the left, I'm going to do something I'm going to call a thinking arrow. It's going to help me see what place value it's actually going. And it helps me as your teacher know and see in your work, okay, you moved it in the right way. Or maybe it was just a silly mistake and you knew to move it the right way, but you still wrote it wrong. So this thinking arrow helps me know exactly where you were thinking with this and if you knew that times 10 moved to the left. So if it's moving to one place value to the left, it's going to now be a 4. Easy enough? Okay, so what about this one? Now, some people will say, there's no decimal. Yeah, not every number needs a decimal. But there is one. This is what number? What value is that? 6, right? So my best way to explain that I've found is say, if I had $6, where would the decimal be? Where's the decimal in every whole number? Right here, right behind it. So if it's dividing by 10, which way is the 6 going to move? You should have said right once. What place value is it? I kind of like, have you ever played Hangman? I put the like Hangman slot for filling in to visualize that place value and where it's at with the decimal. So maybe that's a strategy you could use too. So now it would be, and I have to have that decimal, and then 6. So it's a 6 tenths because it moved one place value. Sometimes you can go back to this key here and find where that number was. For example, it was 6 wholes, and actually do that movement and see, okay, now I'm in this place value. You could even go here and see the different slots as well to help you visualize where that digit is moving to. So every single place value is worth 10. So depending on which way I'm moving, it's moving to that next place value. All right, let's see if we're ready for a little trick question here. 4.7. Hopefully you didn't say that. So reading a number like a mathematician that you are, yes you are, how would you say that number? So it's not 4.7. Yes, that's a quick way to say it. Yes, we know what you're talking about, but we are getting very good at speaking in correct place value terms. It makes us practice knowing the different place values and the worth of this number instead of just writing it correctly. So, how do you say it? Should have said 4 and 7 tenths. So you read it like it's a whole number, 4. You say and because there's a decimal. And then, so 4 and you say the 7, but I said something after the 7. What did I say? I said tenths. So that's because the 7 is in what place value? The tenths place value. So the 4 and 7 tenths. Okay, what's happening to this 4 and 7 tenths now that we're saying it correctly? Well, it's timesing by 10. And if every place value is worth 10, this 4 and this 7 is going to move which way? Both of them have to move. You said to the right. And that means, and so with 2 digits, it gets a little congested here. Maybe you can visualize it and you can see where those numbers are now. But if not, I do like I said, my hangmans. And then here's my decimal. Okay, so this 4 is now in this place value. Okay, But the 7 would have followed right along with it, right? Next to it. So the 7 is now right there. And my decimal is behind all of it. So my answer is 47. Now, you may be wondering, it's a good question if you are, can I put that decimal there? Here's what you ask yourself. Is it still 47 if I put my decimal here? Yeah, it's still 47. So can you? Yeah. Do you have to? No, it's still 47. Now, some people would even put a 0 behind it. Is your number still 47? Then you're good. You can put it there. It would not make it wrong, and it's not necessary to make it right. Okay, what about this one? So I'm throwing that inverse at you, which is tricky because you see multiplication, and all of these multiplication ones we've been moving to the left. So if you were multiplying, you would think it's to the left. However, it's a tenth. That's the opposite. It's the inverse of dividing 10. So this is the same thing as dividing by a 10. Okay? No division symbol, multiplication symbol here though. So this 3, what's going to happen to this digit? Which way is it going to move? You should be saying it's going to move to the right. And when it moves to the right, what place value is it in now? Tens. So can I just put my 3 there? Well, I would have 3. 3 would be my answer. Is that the answer? You said it was in the tens place. Is this in the tens place? Technically, it's not. It's in the ones. So in order to keep that 3 in the tens place, we are going to have a 0 here. And then that way the 3 is in the correct place value, making our answer 30. So let's look at kind of some of these values and how they compare. So let's first look at this 7 and this 7. And notice I did not say the value. I want you to think about how you would say this. So this would be, think about, how would you say this number? 7 tenths. And this is 7, in what place value? 7 hundredths. So go back to the top of your notes. That's why we're writing them. If you need to refer back to it, you can say, wait, where is that place value? Here's the decimal, count how many over, and then find what that name is if you need to. But the hope is that after a while, you're not having to look back at all, and you have those memorized. You won't be able to use those notes, and I don't want you to have to take the time to use those notes in the future. You should be able to just get it quickly. So if we have tenths and we have hundredths, we're kind of looking at how those and how so back in elementary school, hopefully you played with these lovely tools, and they are called base 10 blocks. So in our base 10 blocks, this has how many boxes in it. So if you can't remember, you can count there, hopefully. You should see 10. And this is 1, right? So there is 1 out of, and then this is 10. So this is going to help you think about the different values and their worth here, because this is considered a whole, okay? And what makes a whole is 100. So if I have 7 tenths, and this is 10, how many of these do I need to shade in? Get my highlighter here at an adequate size for shading in such an item. And you should shade in 7 tenths. So I have 1, 2, 3, 4, 5, 6, 7. 7 tenths. Okay. Now, if I have 7 hundredths, I have 1/100th, 1 out of the 100. So it's 7 of those units I will shade in. So 7/10 is 7 rods, and then 7/100 is 7 units. Okay. Now, what's interesting is this one kind of can look bigger because it has more digits there. This one looks smaller because there's not as many digits, but look at the actual value. Technically you have 7D hundredths in 7/10 being the same thing. So this one, even though it looks smaller, value-wise, its place value is bigger. So if we go back to our place value, as we move to the right, the value gets smaller. We went from tenths to hundredths. Now, we don't have a tool to show us thousands because that would be this cut up into more and more pieces. Okay, so actually into 10 itty bitty pieces. So as we move to the right, the value is getting smaller. And then as we move to the left, the value gets bigger. So no matter where we're at, that is going to be continuous. And you can see that in the grids here. Okay, so now I want you to try this one. It's very similar. So what is 4/10 shaded in versus, and maybe this one, 40 hundredths shaded in? This one is really interesting. So think of when we had hundredths and we had tenths. The digits the same, but there's a trick that might explain here with this one. Think about what would you do? And for those of you not using the notes page, you can just draw these different types of rods to straight up and down. And then this one could just be one box, one unit, so you don't have to draw a box with 100 pieces in it. So what are we thinking here? 4/10. Well, that one is very much like our 7/10, right? So our 4/10, we have 1/10, 2/10, 3/10, 4/10. Okay. So 4 of those rods, 4/10. Got it. How would you say this? It's 40, and what place size go to? It goes all the way to hundreds. 40 hundredths. Remember we said hundredths is this unit cube, right? So 40 of these. That'll take a while. 1, 2, 3, 5, 6, 7, 8, 9, 10. Well, that's 10. So I need 40. Okay. 2, 3, 4. Is that 40 of these? Interesting. 4/10 shaded in is the same thing as 40 hundredths. Look how that even lines up. The 4s are in the same place value. How much value is in this hundredth spot? 0. Nothing. So they're equal. 40 of these is hundredths is the same thing as 4/10. So these extra zeros don't have a value, therefore they do not change the value of where these 4s are at. So I mean I could have a 0 here. I could have another 0. Now we'd read it different. It would be read completely different, but it's equal value to all of these. So how would this one be read? 400, and what place values go to? 400,000. The same as all of these. I mean, you could keep going and going and going and going and going, and they're still going to be equal because zeros behind a number in the decimal place value does not change the value. Okay. Now, if I had a regular 4 holes, and I put a 0 after it, does that change the value? Okay, it went from a 4 to a what? 40. $4, $40. Yeah, it definitely changed it. So it's not that zeros won't change the value. Zeros after the decimal will not change the value. Okay? So this is just another way to look at that pattern of how if times 10 would change and move that digit, okay? Or if it was times a tenth, what's the same thing as times 10? Dividing by 10, right? And how it would push back that digit into smaller place values. So we're going to look at two questions that are having us continue that pattern with a different digit. So one up here, but this one it looks like we're using a 7, and we have some different blanks to fill in of where this one 7 is going to move to. And for this question, it's saying for 10 times. That's our pattern. So if the 7 starts in this place value, what place value is that again? Thousands. So then if it's times 10, which way is it going to move? It's going to move to the left. So I'll put my thinking arrow in there, and it helps me know that it's going to the place value in front of it. And what is that place value? So you know you need your decimal, you need a placeholder 0 in order to keep that 7 in this place value, and it is the hundredths place value. So I'm showing that 7 is moving up to a higher place value, worth 10 times more than what it was. So they already have this next one done for us, but I'm still going to show it for practice purposes. So our 7 is in the hundredths. We're still continuing that times 10 pattern that we did. And so then it should now be in the tenths place, and it is. So they already did that one for us. Okay, but now if it's in the tenths place, times 10 pattern again, what place value is it in? In the ones. It's a 7. So now the decimal is behind, and we're in our whole numbers. So if this 7 moves to the left because of times 10 again, we're actually going to have to put in those zeros to keep that 7 and hold that 7 in place to then have a 70, right? Okay, what about 1/10? Yeah, 1/10. Which way is it going to move? 1/10 pattern. We're going to try that with our 6. I can see where the 6 is moving. And this can get kind of confusing, so I still like to go through like we did here and even try it once we've already had one of the previous answers given to us. All right, so we have a 6. We have 600. And what's happening to the 6? It's going to move to the right because it's getting smaller when we go a tenth of something. So now it should be a what? Hopefully you said 60 because it's moving to that smaller place value. That's the tens place value. So then same thing here. If it's moving to the right one place value, it's in the ones place. So that's why we had just a 6. That was already given to us. And if we move to the right again, this is where I like not just a thinking arrow, I'll put in a decimal. That comma is there because it's just showing the list of those patterns. But then I'll do kind of my hangman style and show that 6 is now in that place value. So it's a 0.6, not the mathematical way to say it. So it's actually 6/10. It's in the tenths place. So now continuing that pattern, we're going to use that 6/10 and go, okay, if we're moving to the right again, because our pattern's 1/10, this value is need the hangman line. So sometimes I'll even put it in my answer spot and go, okay, here's my decimal. That 6 was here, but now it needs to be in the one next to it. And so then I'll put the 6 there. I can't leave the 6 just hanging there by itself because that's still 6/10. There's a decimal and there's a 6. That's 6/10. So in order for this to be a 600th, that 0 needs to hold it in its place value. Very similar to a 0 holding the 7 in that place value as it was getting larger. Okay? So the main takeaways, when a digit moves to the right, is it getting smaller or bigger? The value. It's getting bigger. How much bigger? 10 times bigger. If a digit is moving to the right, the value is getting smaller. How much smaller? A tenth smaller, right? We're dividing by 10. So if we have these values and we are going to write the value of that digit, let's fill in these boxes using the grids and starting with that. So what amount do we have here in our grids shaded in? So if this was 100th and this was a 10th, how much shaded in this one? A whole, right? And so if this is a whole and this is a whole, we have our number is 2. 2 wholes, right? So we have 2 ones is the value of our digits. And then what about this one? We have 2, but 2 what? How many are there? It would be 2 tenths. And how do we write that in our digits? So we have the decimal, and this place value is the tenths. Getting smaller. Still have 2, but 2 what? Those aren't tenths. That would have to take a whole rod. So that is hundredths. Squeeze that in. So how do we write that one? A decimal. 0 has to hold the 2 in the correct place value. 200. So let's talk about how these 2's all relate to one another based on what place value they're in. So if we were doing 10 times, so I'm going to write these up here because I can't see them, but you have them on your paper. So we had 2, we had 2 10s, and then we had 2 hundredths. So we're going to write all the equations possible to show the relationship between the numbers, okay? So times 10. So that means the digit would be moving to the left, right? So we could start with at least thinking about an equation has an operation. In this case, we know it's multiplication and what we're multiplying by. And an equation always has an equal sign. So what we're missing here, other than what they told us, is one of these 2 numbers. So we need to figure out which one of these could be multiplied by 10 and equal one of the other ones. What do you think? Sometimes it might just be trying and seeing what you could possibly get. So we use a different color to see it. We have it listed here. Let's try it. 2. If I started with 2 and it times by 10, we said the 2 is going to go this way. What place value would it be in? It would be 20, right? Not an option. Okay, so I can't start with the 2 wholes. Let's get rid of that one. Try 2 tenths. Okay. So if I have 2 tenths and that 2 moves one place value to the left, because it's times 10, what would we end up getting? It would be in the 1, so we get 2. Is that one of our options? It is. We use that one, and we use that one. Okay, we got one of them. There's 3 of them. So we're going to be doing times 10. We know we're going to be doing times 10 for all 3 of these. All right, let's mix it up. We know we already did 2 tenths. So then now let's try a different one. We know we tried this one. So this, try that. All right, I'll use my other color again. So what is that? 2. That's 2 hundredths. If that moves once to the left, what do we get? This times 10. We get 2 tenths. All right. So we used them. We used 2 hundredths and then we got 2 tenths. There's one more relationship. What could it be? Could we have another one? Well, it couldn't be times 10. We've used all options times 10. But is there another possibility for multiplying? This is an advanced question for what we're doing. I wouldn't say hard, but for what we're doing. What other equation could we make? What if we started with 2 hundredths again? Is there something we could do to get one of these answers, but not have the same thing again? So I can't do times 10. I would just get the same one as here. This. What would that be? Can the 2 hundredths move to become 2? If it moves times 10, that would be 2 tenths still, not 2. Have to move again. That wouldn't be times 10, that would be times what? Times 100. And that's possible, right? Well, you didn't say times 20, that would be adding. 10 times 10 is 100. So kind of getting you thinking a little bit further, and that's coming up here in our next lesson. Let's see about dividing by 10. What could be divided by 10? So it would have to move which way? To the right, okay? So if it's moving to the right, let's try starting with something. What if we started with 2 again? We tried it on that one. If it's moving to the right, remember the decimal's here, and it's moving over 1, it would be in what place value? 2 tenths. Moved over. Okay, so what about another one? Could we do another divide by 10? What would it be? What do you want to try? What if we tried our next one here, another option, 2 tenths. If we were at 2 tenths and it moved to the right because it divided by 10, we would have, well, my hangman here. Looks like we would need a placeholder 0 and our 2 would be in the hundreds. Ah, we got one. Any other divide by 10s? We started with 2 hundredths. Divided by 10 is only going to make a 2 thousandths, and 2 thousandths isn't an option. So we definitely can't start with that. We tried both. We did all of them already. This must be another trick one. So, what could we try that would be dividing? Could I start with a 2? Started with a 2, and I got, well, we already did 10. We already did 2 tenths. We haven't tried this one yet. 2 hundredths. What would be happening? Not divide by 10. You're thinking a little bit with this one. So what could it be? If this moved all the way to the hundredths place, it would be dividing by 100. Here's the decimal. Thinking arrow. Moved over 1 place value. There, it's in the tenths. Move over again. It's in the hundredths. So that is relationship 2, just not divided by 10. Ooh. 1/10. 1/10 is the same thing as divided by 10, right? But your equation is still going to be different. So let's practice it with that. So divide by 10 is the same thing as times 1/10. So we can kind of utilize what we've already talked about here, that if I had 2, it's going to move it back to the 10ths place value, right? Same thing here. It's times the 10th. We used a 2/10, and it moved it back a place value. So it became a 200ths. Okay, same thinking here. How would I write divide 100 but in fraction form? The inverse. What do you think? So I know it's got to be multiplication and there's going to be a fraction. What do you think? Hopefully you said 100. So see the similarities here? The 10, the 10. And it would be the same numbers that we start with, 2 wholes, and it would have to move 2 times to get to the 2. So we can see that not only are we utilizing, if it's times 10, which way is it moving? If it's divide by 10, which way is it moving? But how some of our values are all related, and we can write those in equations. So we're going to need to know what we get and utilize that movement, and also be able to tell which operation's happening if the movement has already happened. Okay, so let's do maybe 1 or 2 problems from our practice. You're going to try it on your own and see how you do. Now remember, this is the first time you're really jumping in this. You're dusting off the cobwebs from the summer. This either came very easy to you or you're still kind of putting it all together. And that's okay. We're a work in progress. We're not taking a quiz today. That would be unreasonable. So sometimes struggling and not knowing and questioning yourself, it's a good thing. It's going to help you learn. It's going to help you progress in your understanding of everything. So it's okay if you're not sure yet. That's why you'll come to here with me and we'll look it over and keep practicing it. And by time we've practiced it enough, you'll get it. So let's kind of put these things into practice. So your question 1, so you do have this on Edulastic, but if you're in class today, you have the paper version 2. But if you are at home, you are doing this one on Edulastic, so you can follow along with us as well. But if you're here at school, you can, of course, still do it on Edulastic and see how you're doing to check your answers. So Huron showed, what is this number? How do you read it? 800. With the model shown. So hopefully you can see your model. I can see that there is some shading here. And just in case you can't quite totally see it, I'm going to leave this in maybe a little bit more right here for you. It's a quick shade. Okay, so that's what's shaded. And here I'm saying is 800ths. The question is, what is wrong? Okay, we already know something's wrong. Marking of the problem is a key element to problem solving. You're thinking about it. If you've circled things, you've underlined things, I can see what you really pulled out from the information. So a blank question is not really showing that we thought about what's going on here and what they're telling us. So that's a big point that, okay, it is wrong. That is not 800ths. We have to say, what could we do to her model to show 800ths? So if that's not 800ths, what would 800ths look like? What do you think? Go ahead and write something down. Give it a shot. So I see 8 shaded there, but that's actually 8 what? 8 what? 8/10. So what could we do? 800ths, that's with these, right? Our units. Cube. So if I'm going to show just 8 of those, we would need to shade 8. You could say what? You could, if 8 what? 8 hundredths. You could actually use the word hundredths. You could say 8 boxes could even be used, because I would know what you mean by those individual boxes. You could say 8 units instead. And one of the things we already said was hundreds. So I'm kind of listing, stacking our options up here. 8 units, 8 boxes, 8 hundredths, and then it would show that value correctly, right? Okay, so go ahead and continue on your practice and put in those answers on Edulastic. Once you click submit, it is going to check it. It's not for a grade. We're so used to saying it's going to grade it. It isn't going to grade it. It's going to tell you what you got right and what you got wrong if it's not one that you typed in. Computers aren't that smart. I'm going to have to read this and check it, and I will, and we'll go over it the next day you're here at school. And you can analyze and see how well and how far along we are in our questions with our first round of practice. So definitely mark up the numbers you're going to be using, underlining the questions. Give it a shot, give it a try, and be ready to ask questions and analyze how we're doing next time we meet.